Hello everyone, I hope you're doing well. So in this video, we're going to discuss Geeks problem of the day, and today's problem is count possible ways to construct buildings, and it is a medium level problem. So the problem is very simple and straightforward. It says that we have been given a road passing through n plots. So I'll just try to simplify this problem a little bit and then explain you. So let's consider this particular case. In this case, the value of n is equals to 3, right? So they have said that there is a road like this and there are 3 spaces on the left as well as 3 spaces on the right. We have to find the total number of ways to construct the buildings onto those spaces such that no two buildings are adjacent to each other. That means basically if I have constructed a building here, I cannot construct another building here, right? So as you can see in this particular example, they have mentioned all the ways. So they have said the first example is building space. So this is a building can be constructed here, then there can be 2 spaces left, right? So currently we are discussing only about one half of the road, right? Remember this. Now we have building space building. So we can construct a building here, then we have a space in between, then we have a building again. Then we have space. That means we construct no buildings at all. Then we have space building space. Then we have, that means a building is at the between and there are 2 spaces, one to the left and one to the right. Then we have space building. That means one space here and one building here. So these are total 5 number of ways in which we can construct the buildings on one side of the road. Now there will be similarly 5 other ways as well, and each of the ways will match with every other way of the other side. That is why we will have that particular number square time. That means the number will multiply with itself basically, and we will have to find the answer as square. So if this part was not clear to you, I'll explain this to you a little bit more clearly. So let's say we had this road and we had one space here and one space here. Now for this particular space, I can independently choose to add a building or leave it as it is, right? For this space also, I can also independently choose to add a building here or to remove a building, right? And together, like when I consider them together, then there will be, let's say this is empty and here is building here, then this is building and this is empty here, then this is building on the left, building on the right, and this is empty and this is empty. So you see, when we have 2 independent ways here, 2 independent ways here, the total number of ways will be 2 into 2. But since the number of spaces on both the sides are equal, so we can also write it as 2 square, right? Now the question simply reduces to, if we have been given a value n, how can we actually find the number of ways to insert buildings on one side, and for the other side we can simply do it square, right? So how do we find it? This can be solved with a simple dp. So I'm going to maintain a dp. Let me just write it. So my dp is going to be like, so dp of ij, I'm going to construct a 2-dimensional dp where I is going to represent the current position I am at, and j is going to represent whether there was a building at the previous position, right? So if j is equals to 1, that means there was a building at the previous position, and if j is equals to 0, that means there was no building at the previous position, right? Now since I have defined my dp, let us discuss some base cases. So what happens when I is equals to n, right? So in this particular case, this means I have exhausted all the possible spaces and I have formed a valid configuration. So in this case, we're just going to return 1, right? And our starting case, our answer will be stored in dp of 0 0. Why 0 0? Because initially we are at position 0, we have not covered any buildings, and since there was no previous building, the previous position cannot have any building, right? So that is why we have 0 0 in both of them. So let me just write the memorization function to help you understand the transition states. Till now I have defined what is going to be my dp, I have defined what is this dp state representing, I have defined what will be the final case, the base case, and what will be our starting case. Now let us write the memorization function. So let's say I have this helper ij, I have defined my base case. So if I is equals to n, I have to return 1, right? Now if dp of ij is not equals to -1, that means it has been already computed. I am just going to return dp of ij, right? So this part is clear. Now I have to make some transitions. So for, let's say let's say we do not receive j here, we are just going to calculate for both of the j's, right? So let's say now we are here. If dp of ij, if you are talking about dp of ij, or maybe let us also have both of them, it will be much better then. We are going to deal those cases now differently. So if j is equals to 0, right, that means there are no previous building, right? That means the position that was before it does not have any building. So I can either decide to make a building here or not make a building here. If I decide to make a building here, I will have to go to the next position and tell that there was a building at the previous position now. So basically now I say if j is equals to 0, that means there was no building at the previous position. Now if there was no building, I can either make a building here or not make a building here. If I decide to make a building here, I will have to go to the I plus 1th position, and for the I plus 1th position, the I position does have a building now, so I have to pass 1 here, right? Now if I decide to not make any building, that is when I will call my helper of I plus 1 and 0, because I am not making any building now, right? So my dp of ij is going to be make, so let me just write it as like this, make plus no make and taking the modulo, right? So this is required in this question, that is why I have included this. Otherwise what I am going to do is, if there was already a building at the previous position, then I cannot make a building here. The only choice I have here is I go to the next position, so I call helper I plus 1 and pass 0, because I will not be able to make a building at this particular position because there was already a building at the previous position, right? So I am passing this 0 by, so let me also draw it so that it is easy for you to understand. So let's say there was a building here, this is my current I position, right? So this is a building. Now this particular state, if I am at the ith position, that means the value of j will be equals to 1. Why? Because there is a building at the previous position. Now for the position I plus 1, I cannot construct a building here, right? For the position I plus 1, j is definitely going to be 0, right? So that is what I have done exactly here, right? Now let's say there was no building, there was an empty space here, right? So this is the case when I is the current position and j is equals to 0, right? So in this particular position, I can either make a building here or not make a building here. If I decide to make a building here, so let's say the building appears like this, then for the position I plus 1, j will have to be 1. Why? Because at this previous position there is a building. But if I decide not to make a building here, so let me just remove this building. Now for the position I plus 1, j will be equal to 0 as well, because this position is empty, right? So these are all the cases that I have done here. So this is the j is equals to 0 case and this is the j is equals to 1 case, right? Once I have figured out these two things, what I am going to do here is, now I am going to return dp of ij, right? So return dp of ij, right? So I have set my answer and I am just going to return dp of ij. So this was all about this particular problem. I have tried to explain the memorization approach, and now we will have a look at the recursive code. This problem is not very difficult, just a simple take or no take dp or a simple knapsack, just with a couple of conditions, right? So now let us have a look at the iterative code. So what I have initially done is I have created a long modulo value 10 raised to power 9 plus 7. I have just taken long to avoid any accidental overflows, that is the only reason. Then I have created a double dimensional dp vector of size n plus 1 cross 2, right? So all of the values are initialized with 1 initially, that is basically for the base case when we reach for the position n, and all the other values we are going to set now, right? So you can ignore this for loop for now, just focus on this particular part. We see that when dp of I1, when we are treating dp of I1, that is when j is equals to 1, I am just directly setting it as dp of I plus 1 0. So that is exactly what I have done here. dp of ij when j is equals to 1 is equals to helper of I plus 1 0, right? Now for dp of I0, I am calculating make and no make. So make is basically dp of I plus 1 1, as you can see here, helper of I plus 1 1, and no make is dp of I plus 1 0. Similarly here, helper of I plus 1 0. So you see everything is same, the only thing is I have written helper in this memorize function and I have written dp state itself in this iterative function, right? So now what I do, I set dp of I0 as summation of make and no make, because these are the possible two ways, and taking its modulo, right? Now what about this particular for loop? As you can clearly see that my dp state of I here is depending on some state I plus 1. That basically means I plus 1 has to be computed before computing I. That is why simply this I is going in reverse order, so that I plus 1 is computed before I. right? So I'm starting from n minus 1 till I is greater than minus 1 and doing simple I minus minus, right? Now at the end, what I do, I just return this the square of dp of 0 0 and taking its modular value. I've already explained why I have taken square. These are two independent events which when occur together, the total number of waves will be multiplication of both the events. But since the number of spaces on both the sides of the road are exactly the same, that is why we can just take the square of the initial value. If these two values would have been different, we would have taken different value of n for the first dp array and different value of n for the second dp array, right? So this was all about this particular problem. I hope that you guys were able to understand the solution. So let me just quickly submit this and show you that this particular code works and this solution is absolutely correct. Okay, so unexpectedly we got a TLE. I just submitted it right now, so I'm just submitting it again. Okay, so we have seen it live. If it at any time it occurs to you and it is giving you TLE, just try submitting the problem again, because I don't know, sometimes it happens with Geeks for Geeks and it does not accept the solutions. So I'm just submitting it once more just to make sure. So it is passing, but if I go to my submission, so we can see that once it gave me TLE. You see these summations are all together at the same time. I don't know, there is some issue with GFG. If you get TLE, then definitely try submitting the problem once again. Right. So that was it for this particular video. I hope this video was helpful for you, and if it was, then definitely consider subscribing to this channel and don't forget to share thoughts in the comments, because your engagement with this particular video really helps the YouTube algorithm to understand that this video is actually helpful for you, and it will be able to reach much more people like you who want to keep solving new problems. So that is it for today. Till the next video drops, keep coding, stay safe, bye bye.